The broadcast is now starting. All attendees are in listen-only mode.
Hello, on behalf of Sigma-HSE, thank you for joining us for our Quantitative Risk Assessment webinar today. We want to give everyone an opportunity to jump into the session, so we will get started in precisely 2 minutes. Hello again. Thank you for joining us today for our webinar on Quantitative Risk Assessment. I am Mark Yukich, U.S. Technical Development Manager at Sigma-HSE, and I will be your host today. I have about 10 years of process safety industry experience. That experience includes combustible dust, flammable vapor, and chemical reaction hazards, and steps to mitigate those hazardous materials while in process. I enjoy taking the time to understand the pain points for our customers related to process safety. If we don't have the option to assist, I want to ensure we hand you off to a team we trust to bring value to your safety team. Please feel free to contact me should you need any assistance. Sigma-HSE is a global engineering firm with technical experts supporting companies around the world by providing actionable solutions to protect, enhance, and optimize their process. Our goal is to allow your team to focus on what really matters: protection for your people, business, workplace, and the environment. In this webinar, we will discuss Quantitative Risk Assessment, or QRA, Hazards, Risk and Safety, Chemical Handling. This webinar will explore core principles of QRA and risk evaluation, identifying chemical hazards, predicting accident likelihood and consequences, and integrating QRA into project planning and compliance. We will have time for Q&A at the end of the session. Feel free to add questions to the questions section during the training, and we will address those at the end of our program. Vinny Simoes will be our process safety consultant leading our discussion today. Vinny, I'll turn it over to you.
Thanks a lot, Mark. I have just quick spiel on myself, right? I know some of you guys have already attended another webinars that I have presented and all, but I have over 24 years of experience in basically safety, just out of college and went straight to process safety. Those include facility siting, incident investigation, hazard classification, PHAs, auditing, and has been my bread and butter, basically consequence modeling and QRA. So we're gonna talk a lot of a subject that I'm very dear to my heart, and we'll just discuss a little bit about it. So the idea of today's webinar is do a quick introduction to QRA in a nutshell. That's what we're looking for. So we're gonna talk about risk versus consequence approach, why one over the other. We're gonna talk about typical risk criteria, general methodology for QRA, and then we're gonna talk about typical QRA requirements. What do we do? When do we do this? We do to determine the risk to people, risk to your asset itself. So you can look into fire and explosion risk assessment things, and then we look into risk reduction measurements, or basically an alarm demonstration. Other requirements that come out of the risk base, we can talk about this in other webinars. We're going to talk this further out. It's escape and evacuation risk assessments, emergency system survivability analysis, risk-based layout optimization, and so far on. So this is basically what we're going to cover over the next 30 minutes or so. So the first question is why risk, right? Why do we move from consequence to risk? The consequence itself, we can only tell you part of the story. So think about this. If I take the worst case in my facility, it's going to make a massive impact, and it's going to be extremely impactful to my environment, to the people around it, and to my asset. The problem that creates is that the likelihood of that becomes very small. So it's that one in a lifetime kind of event. So we rarely design based on the worst case, right? So you look even like for buildings and so far on, there is an acceptance in there, and that's what we're going to talk about it, because very rarely this dominates the risk. When we put the consequence, you're going to see that those are really not going to be the ones driven. We'll talk about total risk of exposure, and that's basically the summation of the risks for all the range of events. So we're going to talk about a possible little leak. We're going to talk about oblivion. We're going to talk about, so all of this got combined and give me a real expectation about what it is. When we take the consequence approach for like what the maximum credible event could be, we're already taking a little bit of that risk into account. So if we mitigate our assessment based on the worst cases, we're going to end up with a very heavy expenditure. It may not be effective because, again, when we look into the whole scheme of things, if I just take the worst case, it may not be the one driving my risk. So that may not be effective. So we're going to talk about modern risk criteria, right? A lot of them, like the UK and the HSE in the UK, the Netherlands, Switzerland, Singapore, a lot of those countries are driven into the risk criteria. They are not consequence based. In the US, for example, we don't have a specific requirement to do QRAs, but all that OSHA requires us to do is to do a siting assessment. And the siting can be done in a risk-based, which essentially is a QRA, or consequence-based. So those are things that, for example, you may not have explicitly asked it to do a QRA, but it may be something that we are already using and we're still already doing. So the information that I'm going to get out of a QRA is basically a location-specific individual risk per annum, those two being individual risks. So basically assuming the risk to a person, to a group of person when we're talking about ERPA. And then we're talking to societal risk, or the risk for the whole society around that asset, which we're talking about the potential loss of life. We're talking about the societal risk in terms of an FN curve, or frequency versus the number of fatality, right? So when we're talking about typical risk criteria or escalation criteria, we're talking about the risk to workers or risk to others, in this case, the public, and the risk of escalation. So looking into one unit in my plant, impacting the other unit. So there's different ways that we do it, right? So when we're talking about risk to workers, we accept a little bit of a heavier risk than when we're looking into risk to public. The risk to workers, mostly around the world, if you are in the 10 to the -3 or once every 1,000 years, it's not acceptable. When we're talking about the 10 to the -3 to the 10 to the -6, or basically every 1,000 years or every million years, you're talking about being in the all-ARP region, or as low as reasonable practicable. And we're going to talk about this a little bit later on. But when we are lower than 10 to the -6, which worldwide, this tends to be a broadly accepted region. So when you think about the risk to the public, it's a little bit different, right? It depends on the land use planning. So countries will have specific to risks to the land use planning, where we're planning to build a facility, what do we need to do? They cannot be higher than 10 to the minus 4. So we're basically accepting that they cannot be higher than that. And then when you have residential areas, they cannot be placed within the 10 to the minus 6 range. There is a different criteria for existing facilities to new facilities. So if you're putting a new facility, a lot of the criteria are going to be a little bit more strict because you already have the public around. But a lot of those facilities were built in the 50s, 60s, where there's nothing around, and then it will start popping up houses and buildings nearby. Then they have a little bit of a different criteria. The risk of escalation, it's based on fire and explosion. So that becomes a company-owned criteria. That's nothing in the industry that tells you, or in the regulations that tells you that you need to do. And then usually a good rule of thumb, and a lot of the assessments that I have done personally, we look into the 10 to the minus 4 between units. So I don't want to escalate an overpressure that would damage equipment to the other unit if it's over 10 to the minus 4. And then for safe critical elements, we get a little bit tighter, right? Of course, because we want to be sure that if we need them, they are there. So they are 10 to the minus 5 per year. So we're talking about different countries and different things, right? So different countries will have different risk criteria. When we're talking about the UK, for example, we're talking about individual risk and possibility of F-N curve, right? And there's other things that you do and other criteria that you do besides the individual, and they are listed there. Like a lot of places you do alarm demonstrations and so far on. So when we're talking about land use planning, then we're talking about, yes, maybe an individual risk criteria, but I'm looking mostly into the societal, because for the land use planning, I'm looking about building around. So that's where we imply that the societal risk is a requirement. In the Netherlands, the individual risk is a must, and the FN curve is optional. When we're talking about the Belgium, we're talking about both of them, individual and FN curve. Same thing for Hong Kong. 3 states in Brazil use both of them. And then if your FN curve meets the criteria, then you're flexible on the individual risk. You may present or you may not present. Singapore is only individual risk, and a lot of the things are related to consequence based. So you do like consequence driven. And then you can see other countries in there. In the US, where I'm based on, we have like basically federal agencies do not require necessarily something. Santa Barbara County is different. They do have a screening, QRA screening for that. But the other ones tend to be like, when we're talking about facility siting, for example, we can use a risk-based facility siting, and then there is a criteria that we present or results that we present to satisfy that. So that, in a nutshell, what some of the criteria around the world. We can talk about 2 or 3 bands, right? In terms of societal risk or individual risk criteria. So usually what we're talking about is that when we have 3 bands, we have an acceptable, we have a LARP region, and we have a non-acceptable. When we're talking about 2 bands, we usually have the LARP region and the unacceptable region. So if you look into the different countries, they would have different criteria and different applicabilities. So when we're talking about individual risk criteria to the public, for example, on the top of this graph, you guys gonna see a little bit of a data about like what's the probability of death from cancer, for example, UK road accidents, death from CJD. So all of those are like just like give you an idea. For example, why don't we design, for example, to the criteria of 10 to the minus 7? Because it's the same likelihood of being struck by lightning. Do we design things associated to that? No, we don't. So that's where it becomes a little bit more of like that 10 to the minus 4 is something that we're saying that you driving to the office, or you walking on the street, or you have an accident at home is the same likelihood. So when we say that we're trying to do that kind of criteria of 10 to the minus 4, we're trying to keep on something that on your day-to-day activities, you have the same hazard. So that's basically where we got to the 10 to the minus 4. And then you have the criteria for individual risk for the different countries listed there. You can see some of them are more strict than others. The Netherlands tends to be a very a very strong criteria, as well as the US. Some of the others play a little bit of a bigger role. There is a big ALARP demonstration region and so far on, but some of the others, like even the ALARP is quite decent. So when we're talking about the land use planning, then it changed, right? So keep that in mind back to what we did initially. But what we're trying to do is like we're having mostly like an area that is unacceptable, which is the red. The yellow is the ALARP, and that purplish brownish color is actually where it's broadly acceptable. So that's basically what we're trying to do. So this gives you an idea about the individual risk and what the criteria associated to this is. On the next slide, we talk about societal risk. So my idea now is to move that into like, okay, now it's not anymore to just a specific area anymore, a specific group of people. Now we're talking in general to all the public workers around. You can do societal risk criteria for inside your facility, outside your facility, and you're gonna see that some of the criteria are changing and they are different. One of the things that I want to highlight, for example, if you take the Hong Kong curve, they do not accept over 1,000 fatalities. So what they're saying is that no matter which frequency I'm looking for, I cannot have over 1,000 fatalities. So in that case, that criteria stops in there. So if I have above 1,000 fatalities, you do need to address the risk because it's going to be unacceptable. Other criteria will change, and you can see that they will depend on the country. They will depend on what tolerance of risk I can do and what tolerance of risk I cannot do. So in terms of a general methodology, if you think about it, it's very similar to what we talked about when we did the facility siting webinar, right? That we're talking about a system definition, and then we define the leak scenario. So basically what we do is we first identify the hazards. Then we generate what scenarios or what failure case we want to assess. Then we need to look into the frequency, right? Because now we're talking about risk. So we're not talking about a consequence only. We're talking about consequence and frequency combined. So after that, we need to look into the vulnerability. So what's the impact that this, what kind of radiation, what kind of overpressure is gonna damage that building or is gonna create a fatality for me? Then we need to look into background data, which will become meteorological data. We're talking about ignition sources. We're gonna talk about population. We're gonna talk about all of this as a whole. And then from that, we're gonna define as well where the congested areas are. That's important to define because once we do our exposures, we wanna be sure that we assume them properly. We're gonna look into then the consequence analysis combined with the frequency analysis, and with that, adding population data, ignition data, and the vulnerability, I'm gonna do a risk, I'm gonna calculate the risk. Then from the risk, I'm gonna look into, okay, is that the risk to people? Is that I'm doing a fire risk assessment? Am I doing an explosion risk assessment? Okay, do I wanna rank the risk? Do I wanna see what the top contributors are? And then I can do, of course, sensitivity analysis. Then from that question, I ask myself, is that accepted within the criteria that I defined? If yes, great. You can even look into other options and look into possibly frequency reduction measurements if you do fall into the ALARP and so far on. But if it's not acceptable, we're gonna need to do something. Usually addressing the frequency is not gonna solve the majority of our problems. So that's where we need to start looking to consequence analysis, back to the consequence and try to create reduction measures to actually my consequence. And that could be a very simple one, like putting a dike on, so putting a bund. So if something happens, if a spill happens, it's contained and reduce the size of the pool. It could be reducing size of vessels, right? It can be like, okay, rather than having one massive propane bullet, I can change to two smaller propane bullets. So if I have like a damage scenario or a blavy out of this scenario, it's not gonna damage, it's not gonna create something that's gonna be a bigger impact to me. So those are things that can be looked into and addressed as part of your assessment, right? So when I think about like how to do a QRA modeling, I'm thinking about in 10 steps. That's the easiest and most simple ways to do it. So first I'm gonna define the failure cases, right? Then I'm gonna do a frequency analysis. Once for the frequency analysis, I'm gonna put that on a little bit of, it can be a spreadsheet or can be a table, however you wanna do it. I just wanna listed everything, like every scenario, what the frequency associated, what hole sizes I'm gonna make, etc. And then I do the consequence modeling. I can actually go in interaction with those two steps. I can go to the Excel spreadsheet, come back to the consequence modeling, come back to the Excel spreadsheet, come back there. So until I get the results reasonable to what we believe is correct. Then we're gonna toss into that, we're gonna toss in initial probabilities, we're gonna put the background data, which is gonna be populations, ignition sources, congested area, and the meteorological condition. We need to think at this point, the weather doesn't only play a whole of a temperature, pressure, stability class, wind speed. It plays a role in terms of direction of the wind. So if you imagine that we put all our congested regions, if something drifts too far out, it will be in one direction, but I don't find any ignition sources, I don't find any congested regions, then it doesn't become an issue. But if it blows in the majority of the time to an area where we're going to have the ignitions, we're going to have the congestions, then our risk tends to increase. So that's something why it's important to have the proper meteorological condition. In terms of vulnerabilities, we're going to put that as part of that, and then we generate our risk, or just generate our report. From that, I can have individual risk, as I said, we can look into FN curves, we can look at escalation, we can look into other measurements that we can take into account, right? So when we look into the first step of that, we're talking about failure case definitions, right? So what are some of the rules? What are some of the things that we do? When do we assume that one section ends or one scenario ends and the other one is going to start? It can be by isolation, can be ESD valves, can be by a flow driver, pressure, is that a pump that changed the conditions? Composition, is that a change in composition? Is that very far or very different elevations? Those can be different scenarios or different sections. Then we're talking about temperature pressure. Massive changes in temperature pressure tends to do that. Spill collection arrangement. So if we collect most of the releases in one specific location, that tends to be a section in there, and then we separate that to another section. So this is, in a way to define. There's different rules, there's different applicabilities. That's the one that I personally use for the last 25 years. So when I talk about meteorological condition, we need to get a proper wind rose. There's several ways to do it. Governments publish them, different airports will collect the data. So usually if you do not have specific data, airports nearby are the best source because they do track the wind direction, wind speed, and so far on. I also look into stability class. That's back to that conversation about like doing more stable and less stable classes. Temperature, and of course I need something that is called surface roughness, which basically is the terrain. So try to represent the terrain. Right, so I'm trying to make it in a way something that allows me to actually have things done in a proper way and try to reproduce what the terrain will be. If we're looking into a CFD model, for example, we do not need the surface roughness because we put the elevations, we put all the obstacles on the way. Our way on this empirical world or the QRA world is try to reproduce what would that be and include that in there. So the other information that I said is that we need to put ignition sources, right? Background ignition probability, so the ignition areas, is something that we always do when we look into societal risk. One of the things that we need to think about, and I want to highlight, for example, if you're talking about the Netherlands doesn't assume strong ignition sources. All they ask you is that you assume that the whole area is a possible ignition with a certain percentage. In other countries, we do use, and if you don't have a specific requirement, we do use not only the background ignition, but we use these strong ignition sources like furnace, open flames, flares, for example, hot oil systems, thermal oxidizer, truck loading areas, roads, places where you can have ignition, right? Besides the ignition, we need to put the potential explosion sites or potential explosion domains. You guys may have PEDs, PES. There's so many terminologies for that, but basically what it is congested areas. Where can I have enough acceleration to the flame that will generate an overpressure, right? So if I just burn a cloud in the open, most of the clouds are gonna burn and just like burn as a flash fire. When I get and toss congested regions into the mix, what happens is that those obstacles accelerate the flame enough to generate an overpressure. And that can be process areas, pipe racks, storage areas, so different areas that I will have that. In addition to the PEDs, we actually also need to do population. So if we're gonna do societal risk, we need to put population, and then we need to define where they are indoors and outdoors, day and night. Different vulnerability, right? I can have different vulnerability for different buildings. So one building, the control room is going to be very different than an administrative building in terms of a construction of that structure. And then we're talking about the process area, people distribute around the process area, control buildings, admin buildings, what is that we have? One other thing that population adds to it is an ignition probability. A person can be an ignition probability in a very simple way. You flip a switch. You flip a switch, that's a possibility of an ignition, right? So all of this is things that are there. Once we combine all of this, we need to come up with vulnerabilities, right? There's different sources of vulnerabilities. One of the big ones and widely used is the TNO books. We have like 4 books, 3 of them are the main books, the yellow, the green, and the purple, which they had those colors. The latest on the purple, they changed to the BEVI guidelines for risk assessment. So it's not anymore a color book, but it's still widely used for their vulnerabilities. Other things that we use are 752, that has a vulnerability of buildings due to explosion events, and OGP. OGP is the oil gas producers in the UK, and they do have a probability or vulnerability table for plants and structures under this link. So with all of that combined, then we get to calculate our risk, right? So the way that we export or present our risk is going to be by the individual risk. So when we look into the risk to workers or public, we're talking about, let's say, a 10 to the minus 6 per year exceeds the plant's boundaries. So it becomes a risk to the public. So it's something that we need to look. The individual risk for workers, for example, in this case, in this study, was 10 to the minus 3 to 10 to the minus 4. So it was within the range that we accept, depending on the country, of course. The individual risk per annum, it's by worker group. So that's basically, you can put like maintenance crew, you can put operators, you can put different ways to actually present, and then you have different of them. So the other thing is that we can use this to identify the risk reduction and measurements and see what the impact will be. So when I look into risk of escalation, I'm looking, for example, okay, now it's from one unit to another, or the impact on an administrative building, the impact on a control room. Are they designed for this overpressure? Are they designed for this accidental load? You know, all of these are things. So for example, if our criteria is 10 to the minus 4 to 10 to the minus 5 per year, this criteria will cover a large area of this plant. If you see the 10 to the minus 4 and 10 to the minus 5 is the blue and the magenta colors in there. So those are basically what they are. We have the potential for escalation between units in the process area. And the good thing is about this is that there's no involvement of the admin building or external areas for this escalation. So if we are looking into all my buildings within that area are going to be designed to withstand a 0.3 bar, we're okay. My only issue is going to be if we go beyond that point and we're looking to other areas. When we're talking about minor escalation or the 0.1 bar, that the majority of the buildings will be designed for it, you may have like to make corrections to windows and little frames and this kind of thing. They will cover the majority of the plant, yes, but it evolves on the criteria of 10 to the minus 4. We will reach the admin building, but the 10 to the minus 4 to the minus 5 are extended beyond the plant boundaries. But again, this is just a minor escalation. I'm not terribly concerned. I'm not terribly worried, because if you look, it barely gets out of the boundary. So it's not something extremely bad. The other thing I can do, or in terms of results, is put what we call exceedance curves. So I can look into the exceedance curves in terms of like for different equipment, for different buildings, and then I do the design accidental load for the 10 to the minus 5 and 10 to the minus 4. So the important part is define what the criteria, what the acceptance is for our risk. And then from that, I can do and define, okay, let's say that in the admin building, I have the 10 to the minus 4 is my criteria. I have 0.13 bar. That's okay. That's accepted. If I was going to the standard of 10 to the minus 5, it may be flagged because that's a problem that's over what the design load was. And then you give that input to the design. So we can do the QRA in several parts of the process. We can do really early in the design. I have done plenty of them in pre-feed, even early feed, so you can get very good inputs for design. And then you can do them to check everything in the end of it when you get to the detail engineering part of it. So that's important. So once we determine which scenario that the risk is unacceptable, one of the things that really helps us is determine the top contributors. So we know which scenarios are popping up and which scenarios are the drivers for the risk. With that, I can try to make it a little bit of a better approach to determine what they are. If you look into that section 9 on this study, for example, the large and the rupture, where basically, if you look into adding them up, they are about like 25% of the risk. So just there, it shows that they are high contribution to the PLL or potential loss of life. When we're talking about this, we can improve spill containment. We can consider alternative for the refrigerant. For example, let's say if this is an LNG facility was using propylene, we can switch to propane, which is less reactive, so it may get a little bit of a less impact. We're talking about also a rupture or a fireball scenario, which is a oblivion, then maybe we're talking about reducing the volume of this scenario. This tank is so far on. Other things that we look into, like, yeah, we can reduce the vessel size, as I mentioned. We can reduce the pressure. We can review the control systems, PRVs, etc. So we do not have a fireball, for example, that will lead to a massive impact in there. The top 10 contributors we can do as well for the specific buildings. So we look into exactly the risk for this was explosion by a couple of different scenarios to the admin building. So we can look into relocating strong ignition sources, put the truck loading area a little bit further out. We can increase separation distance between the units. We can consider a high design accidental load for the admin building. So all of this is things that will help us to determine what is recommendations, what is things that will come out of the study as things that we can address to make it a little bit better for us. So in the end, it's like, what do we try to do for you as a project is be sure that we're in every step of the way. Be sure that we can cover you guys in the pre-feed or even concept selection phases all the way to detail engineering. It is important that you do determine the risk and the high drivers for your risk really early on so you can actually design. Our consultants have over 30 years experience in this area, so it's quite a massive overtake that we have. We have our innovative methodology, as I mentioned on the facility siting website. We do work with combining some CFD with some of the empirical models to actually do a little bit of a more realistic result and less expensive solutions. And then, of course, we look into cost-effective solutions. So we try to deliver a balance of safety, compliance within the budget that the client will have. So this is some of the things that we try to achieve. And then with that, I open up for questions.
All right, thank you, Vinny. If you have any questions, please add them to the question section on the right, and we'll work on getting you an answer. First one we have here, Vinny, can we start with consequence and move to the QRA?
Yes, there is studies that have been done exactly that you go into the consequence and you figure out that it's going to be so expensive to actually address those recommendations that people tend to sharpen the pencil by going into a risk-based approach. So that absolutely is something that can be done.
Excellent, thank you. If my country does not have a QRA requirement, can I still do a QRA, and which risk acceptance should be used?
So you can still do a QRA. The QRAs use it. Some companies have their own standard to do it. The big question in there is going to be like, it's a risk acceptance. So if your country doesn't have a requirement and your company doesn't have a risk acceptance criteria, it becomes a little bit of a challenge because you're accepting a risk. So a lot of times involves like, it's a corporate decision about what kind of risk we can take, because there's different impacts, there's insurance, there's different things involved. So recommending a risk criteria becomes something completely very complicated. One of the things that we have done before is do risk criteria workshops. So we do risk criteria workshops with different parts of the company, and then come up and help with defining what the good risk criteria would be.
All right. Are there any other ways to determine the frequency besides the databases?
There is different ways. Years and years ago, I did publish a paper on using fault tree analysis to determine frequency. So there is a way that you can do through fault tree analysis. Back in the 80s, that's how people used to do. Nowadays, you have several databases, HCRD, or the Hydrocarbon Release Data Bank. You have OGP, the same OGP, the oil gas producers. They have a frequency table. The Purple Book has a frequency table as well for what they're doing. So yeah, there is ways to do frequencies besides a database.
All right. Is a full CFD QRA available?
So there's possibilities of doing. The problem is that will become cost prohibitive, and it will become extremely time consuming. We're talking about something that we normally do in about 4 or 5 weeks. We'll probably going to be taking 7, 8, 9 months to do it. So it becomes quite cost and time consuming. So I saw a couple other ones. I'm gonna answer some of them, and of course I'll let some of you guys deal with that. I'll answer some of you guys afterwards. The FN curve is an acronym for frequency versus number of fatalities. So yeah, that's what the FN stands for. Then the other question is that for countries that have a individual risk criteria but no clear FN criteria, what are the considerations that I need to do? So if you do not have societal risk criteria defined by the country, it becomes something that if you're gonna take it an approach and use it, it needs to be, again, a company decided one. That's basically one of the things that you need to be careful in there. We will be providing the recording of that. I can look into the possibility of providing the slides. We'll talk and see what we can do. And then the last one I cannot read completely. Can you read that one, Mark?
I think, is that the one that, yeah, I can't read it completely either myself, but we'll get back to, we'll certainly get back to you on an
We'll
answer
get
on
back
that
to
one.
you guys. It's like, yeah, the ones that I can, there is one or two more questions that I cannot pull out completely, but we'll come back to you guys on the questions. So if we didn't get your question today, oh, you will come back with the answers when we send you guys a recording, you know.
All right.
Oh,
Well,
I found one.
You did? Okay.
For failure case scenario for an old plant without automatic valves, or ESD, what's the best way to define it? It will basically be like we're saying in the beginning, either flow or pressure. Things that will change conditions drastically, it's when we're gonna define the different sections. Sorry, Mark.
All right. No, you're good. I appreciate you digging those out. So, I think we're good on that end, unless we have another question that pops up. But I think we just want to thank you all for joining us for our discussion today, covering quantitative risk assessment. And should you need any assistance with testing and or process safety support, please feel free to contact us at info-us@sigma-hse.com. We look forward to being a resource to you soon. Have a great day.